Next preparation method of haloalkanes from hydrocarbon. So in this topic many reactions are repeated which we have studied earlier in the case of chapter, that is hydrocarbon. So if there is any confusion related to the topic hydrocarbon in the preparation of alkanes, alkenes, alkynes, or the chemical property of alkanes, alkenes and alkynes, then you can watch those videos so that your concept will be clear. So you will clearly understand all the reaction which I will be going to do for the preparation of haloalkanes from hydrocarbon. I also made the chapter wise playlist, so all the content related to that chapter is covered in the playlist. So you can watch the playlist so that your whole chapter will be covered. So let's start the preparation of haloalkanes from hydrocarbon. So first is addition of halogen acid towards alkene. So first of all, what is the order of reactivity of halogen acid? Order of reactivity of halogen acid is given as most reactive is Hi, then HBr, HCl, and least is HF. So this is the order of reactivity of halogen acid towards alkenes. Further, if we take unsymmetrical alkene, this is unsymmetrical alkene in the presence of halogen acid, example HBr. So in this case, this reaction is taken place by the mechanism in which there is a reactive intermediate which is formed is carbocation. So in this case, the mechanism is occurring by the help of formation of carbocation. So how the carbocation is formed in this case? First of all, this HBr is ionized to give H plus and Br minus. So first electrophile, this H plus will attack on the double bond position. Because of that, this double bond will be moving to this position. So carbon will be having negative charge on which this H plus will be attacking, and in this second carbon there will be positive charge will be created. It means this reaction is taken place by the help of carbocation formation. Further, what is happening? This nucleophile Br minus will be attacking on the carbon which is having less number of hydrogen and having positive charge. So this reaction is known as Markovnikov addition. We earlier studied the Markovnikov addition in the chemical properties of alkenes. So in the case of Markovnikov addition, the nucleophile, this Br minus, is attacking on the carbon which is having less number of hydrogen, and this type of addition is known as Markovnikov addition. So in this case, there is a formation of CH3, CHBr and CH3. So this is more substituted alkyl halide. It means Br is present on the carbon which is having a less number of hydrogen. So this type of reaction is occurring by the help of Markovnikov addition. Whereas anti-Markovnikov addition, we have studied anti-Markovnikov addition in the chemical properties of alkenes in hydrocarbon chapter. So anti-Markovnikov addition is just opposite to Markovnikov addition. So what is happening? Anti-Markovnikov addition is occurring in the presence of peroxide. So in this case, if we take unsymmetrical alkene in the presence of HBr, so this reaction is taken place in the presence of peroxide, example benzoyl peroxide. So this reaction is taken place in the presence of peroxide. So this reaction is also known as peroxide effect or Kharash effect, and in this case there is a 1 degree or primary alkyl halide is formed which is just opposite to that of Markovnikov addition. So this reaction is known as anti-Markovnikov addition because in this case negative part or Br, that is bromine, is attacking on the carbon which is having more hydrogen. Because of that there is a formation of a primary alkyl halide is taking place in the presence of peroxide. So there is a formation of CH3, CH2, CH2Br. In the presence of peroxide, mechanism is taking place by the formation of free radical. So first of all, in this there are 3 steps. First step is initiation. In initiation there is a generation of electrophile. So this benzoyl peroxide, homolytic fission will be taking place of this benzoyl peroxide, because in this case there is oxygen, single bond oxygen is present, and this is unstable, this bond is unstable. So there is a homolytic fission is taking place. Both the oxygen are taking away one electron of the shared pair. Because of that, there is a formation of C6H5CO. Odd electron is coming on the oxygen. So 2 moles of this free radical is formed. Further homolytic fission is taking place of this phenyl carbon bond, due to which carbon double bond oxygen will be formed and phenyl free radical. So there is a formation of CO2, 2 moles of CO2 and 2 moles of phenyl free radical. Further, in the presence of phenyl free radical, this HBr bond will homolytic fuse. So homolytic fission is taking place. Because of that, this hydrogen free radical will be combining with phenyl free radical, due to which there is a formation of benzene and generation of Br free radical. So this Br free radical is generated. Further, this Br free radical will react with alkene in the propagation steps. Br free radical which is generated in the initiation is reacting with unsymmetrical alkene. So in the presence of this Br free radical, homolytic fission of this pi bond is taking place, due to which there is a generation of secondary free radical is taking place. This is 2 degree or secondary free radical. This is the first step of propagation. In second step of propagation, this secondary free radical will further react with another molecule of Hb radical, will attack on the hydrogen. Because of that, homolytic fission is taking place in this hydrogen bromine bond. So this hydrogen free radical will combine with this carbon free radical, and again there is a generation of bromine free radical is taking place. Because of that, this reaction will continue to occur, due to which this step is known as propagation step. Because in the propagation step there is chain reaction is taking place, because in every second step there is a generation of Br free radical. So what is happening in the second step? There is formation of CH3, CH2, CH2, Br and generation of free radical. So this free radical will further attack another unsymmetrical alkene. So there is a chain reaction is taking place. So to stop this chain reaction, all the free radical which are formed in the propagation step are terminated in the third step, which is known as termination. So this step is known as termination. In this step, all the free radical which are formed in the first and second step of propagation will be joined together, so that they will be terminated. So in propagation step there is Br free radical and secondary alkyl halide free radical is formed. So these free radical will combine with each other in every possible way. Because of that, this reaction will be terminated. It means it will be stopped. In the case of anti-Markovnikov addition, this reaction is only taking place in the presence of HBr. It is not taking place in the presence of HCl, HF or HI. Because in the case of HBr, both the steps of propagations are exothermic. Both the steps which are occurring in the propagation step are exothermic in the case of HBr, whereas in the case of HCl, HI and HF, one of the step of propagation is endothermic. Because of that, this anti-Markovnikov addition is only shown in the presence of HBr. Second, by addition of halogen, we also did this reaction earlier. So in this case, in the presence of alkene, when react with Br2, So there is, this reaction is taken place in the presence of CCl4, carbon tetrachloride, which is non-polar solvent. So there is addition of halogen is taking place. So this reaction is used for unsaturation test, because in the presence of alkenes or alkynes, the color of bromine, which is orange red color, which decolorizes in the presence of alkenes and alkynes. Because of that, this reaction is used for unsaturation test, because this reaction is not given by saturated hydrocarbon, it is given by only unsaturated hydrocarbon. Next is allylic halogenation. So what is happening in this case? Example, CH3 CH2. So in this case, reaction is taking place in the presence of halogen and temperature of reaction is 773 Kelvin. So in this case, halogen will be substituted on the carbon which is present alternate to the double bond. So this carbon is allylic carbon. So the carbon which is allylic, so this carbon hydrogen will be substituted by halogen. Because of that, there is a formation of allyl chloride is taking place. So in this case, question generally asked, why in this case addition of halogen is not taking place? Why in this case substitution is taking place when there is a presence of a double bond? So why in this position of double bond halogen is not added as in the case of above reaction? Because at this high temperature addition reaction become reversible. At this high temperature, when this halogen is reacted to the double bond position, so there will be formation of CH3, CH, Cl, CH2, Cl. So this addition product is less stable at this high temperature. Because of that, reaction become reversible. Whereas at high temperature, substitution is stable. It means substitution reaction is not reversible. This is substitution reaction, because in this case chlorine atom is replacing hydrogen atom. So this is known as substitution, and substitution reaction is stable at this high temperature. Because of that, substitution is taking place at allylic position, due to which there is a formation of allyl chloride is taking place at this high temperature, not this compound. For allylic bromination, we take another reagent which is known as N-bromosuccinamide. So what is the formula of N-bromosuccinamide? So this is N-bromosuccinamide. So what is happening in this case? This bromine will attack on allylic carbon. So this reaction is taking place in the presence of peroxide. It means this reaction is occurring by free radical mechanism. The formation of allyl bromide is taking place. So this is much better method for bromination at allylic position, because this reaction is taken place in the presence of a specific reagent which is used for allylic bromination. So there is a byproduct which is formed is known as succinamide. So this is succinamide. Similarly, for chlorination, there is another method. So for chlorination at allylic position, we can use sulfuryl chloride. This is sulfuryl chloride. This reaction is taking place at 475 Kelvin temperature, and trace of peroxide is taken. So this reaction is also taking place by free radical mechanism. Because of that, there is a formation of allyl chloride is taking place, and removal of byproduct SO2 and HCl. So both these byproducts are gaseous, so they will easily remove. Because of that, this allyl chloride will be formed in a pure state. These two methods for allylic halogenation is much better in comparison to above method. This method is also taking place by free radical mechanism. Next halogenation reaction will be seen in saturated hydrocarbons. So this reaction is also taking place in the presence of light or heat. It means it is occurring by the help of free radical mechanism. We studied this reaction earlier in the case of hydrocarbon, that is chemical properties of alkane. So what is happening in this case? CH4 is reacting with Cl2 in the presence of either light or heat. Temperature of the reaction can be 520 to 670 Kelvin. So at this temperature there will be free radical mechanism is taking place. Because of that, the mixture of products are obtained. So one product is a chloromethane, CH2, Cl2, CH, Cl3, chloroform, CCl4, that is carbon tetrachloride. So in this case, reaction is taking place till all the hydrogen of this methane, this carbon, is not substituted with halogen. So this reaction is taking place by the help of free radical mechanism. It is having a less significance because in this case there is a mixture of products are obtained. So it is difficult to separate all these products. But by using long fractional distillating column, we can separate these products from the mixture. In the case of higher alkanes, example, in the case of higher alkanes on monohalogenation, they are also giving the mixture of product. So on monohalogenation, in the presence of light or heat, there is a mixture of product is obtained. So in this case, the mixture of product is obtained. So this mixture of product, this halogenation is depending upon the type of hydrogen which is present in alkane. In this case, this 2-degree alkyl halide is more stable in comparison to 1-degree alkyl halide. Because of that, this is the major product, a minor product on the basis of the replacement of the type of hydrogen. So more reactive hydrogen towards halogenation is 3-degree, then 2-degree and 1-degree. Next reaction is iodination of alkane. So in the case of iodination, when CH4 is reacting with iodine, this reaction is reversible because the rate of reactivity of iodine towards substitution reaction is least. So in this case, there is a formation of methyl iodide and HI. Because of the formation of this HI is hydrogen iodide is a moderate reducing agent. So this will again react with methyl iodide. Because of that, this reaction is reversible. Due to which, for removal of this HI, we have to use oxidizing agent to increase the production of methyl iodide. So the oxidizing agent which are used in iodination are iodic acid, HNO3, nitric acid, or mercuric oxide. So these oxidizing agent help in removal of this hydrogen iodide from the product side. Because of that, the production of this methyl iodide will increase because it will be following Lee-Chatelier principle. Because on the removal of this hydrogen iodide from the product side, this reaction will move forward direction, due to which the production of methyl iodide will increase. Another method for the preparation of alkyl iodide is halogen exchange method, and this reaction is named reaction. It is known as a Finkelstein reaction. So what is happening in this case? Either we take alkyl bromide or alkyl chloride. So the reaction of these alkyl halide is taking place in the presence of sodium iodide, which is dissolved in acetone. So this non-polar compound is soluble in acetone. Similarly, sodium iodide is also soluble in acetone. Because of that, there is a reaction is taking place. So there is a formation of methyl iodide is taking place and removal of NaBr or NaCl. So this reaction is also taking place by following Le-Chatelier principle, because in this case this byproduct NaBr and NaCl are not soluble in acetone, due to which they will deposit at the bottom of the flask, due to which, because they are easily separated as they are not soluble in acetone, due to which the reaction move towards forward direction. Because of that, the production of methyl iodide is increased by this halogen exchange method. This reaction is also named as Finkelstein reaction. Next halogenation reaction is fluorination of alkane. In this case, in the presence of pure fluorine, when alkane is reacted, this reaction is highly explosive. It is because this reaction is having less significance. It is because the bond dissociation energy of fluorine-fluorine bond is very less. Very less energy is required to break fluorine-fluorine bond. How much energy is required? 158.8 kilojoule per mole. So during reaction, this reaction is taken place by the help of free radical mechanism. So during the termination step, when fluorine free radical is reacting with alkyl free radical, so this reaction is highly exothermic. So then when the formation of alkyl fluoride is taking place, so during this termination step, very large amount of energy is released. This reaction is highly exothermic. So the energy is 447.7 kilojoule per mole, which is a very high energy. So this much high energy will cleave the carbon-carbon bond which is present in this alkyl free radical. We know that in the case of hydrocarbon, the energy required to cleave this carbon-carbon bond is around 347.3 kilojoule per mole, which is less than this much of energy. So because during this reaction very large amount of energy is released, which overcome this amount of energy which is needed for the cleavage of carbon-carbon bond. Because of that, the fission of this hydrocarbon molecule, due to which the desired product is not obtained. Because of that, this reaction is having less significance. So instead of using pure fluorine, we use diluted form of fluorine, in which the fluorine is diluted with the inert gases, example argon or nitrogen. We can also use inorganic fluoride, example ASF3, SBF3, AGF, COF3. So in the presence of inorganic fluoride, when we take alkyl chloride and react with AGF, so there will be replacement of halogen is taking place, due to which there is a formation of methyl fluoride and removal of AgCl. Similarly, we can take another alkyl halide also. We can also take alkyl bromide. So in this case, halogen replacement is also taking place. This reaction is having more significance in comparison to above reaction, and this reaction is known as a Swarts reaction. In the case of when there are more than one halogens are present at particular carbon, example in this case, this carbon is having two halogen. So in this case, we can use another inorganic fluoride in which there is more than one fluorine is present. So in this case, we can use Hg2F2. So there is a formation of CH3F, CH3 and removal of Hg2Cl2. Next preparations method of haloalkanes from silver salt of fatty acid. So in this case, we CH3, CH2, COOAg. This is silver propanoate in the presence of Br2 and CCl4, that is non-polar solvent. So the refluxing is done. Formation of CH3, CH2, Br, that is ethyl bromide, and removal of AgBr and CO2. So in this case there is a removal of CO2 is taking place, due to which this is a descent of series, because the product which is formed having less carbon in comparison to the reactant. So the order of yield of alkyl bromide is given as 1 degree, 2 degree, 3 degree. So this reaction is more preferred for the preparation of 1 degree alkyl halide. It means the yield of 1 degree alkyl halide is more than 2 degree and least is 3 degree. In the case of chlorination, this reaction is having less significance because the yield is poor. So this reaction is known as Borodine Hundsdiecker reaction, or simply called as Hunsdiecker reaction. Similarly, in the case of iodine, in the presence of CCl4, if we take silver salt of fatty acid, so this, what is the name of this compound? This is silver ethanoate. This is silver ethanoate. So in the presence of iodine, there is a different compound is obtained. There is not formation of alkyl iodide is taking place in the presence of this silver salt. So in this case there is a formation of ester is taking place. So there is a formation of methyl ethanoate. This is ester, and removal of CO2 and AgI. So in this case you have to balance the reaction. 2 moles of silver ethanoate in the presence of iodine. So there will be formation of 2 AgI, silver iodide, removal of 1 CO2 and formation of 2 moles of methyl ethanoate. So in this case this reaction is different. It is not named as Hunsdiecker reaction, whereas the name of this reaction is Birnbaum-Simonini reaction, because in this case the compound which is formed is ester. It is not alkyl iodide, whereas the above reaction in which there is alkyl halides are formed, this reaction is known as Hunsdiecker reaction.